we are doing 10.2 notes, exterior angles of polygons. So we have over here our regular pentagon. Pentagon means 5 sides. And you'll remember from 10.1, the sum of the interior angles is 180 times n minus 2. N is the number of sides. So for this one, we have 180 times 5 minus 2, which is 180 times 3, which is equal to 540. So the sum of all the angles of this pentagon inside are 540. So one interior angle, if we just look at one of them, we're going to take the 540 and we're going to divide it by 5 because there's 5 angles, and we're going to get 108 degrees. So this one angle is 108 degrees. The formula, if you remember, is 180 times n minus 2 divided by n. Okay. So if you look at the angle you just did, the exterior angle over here, you'll notice those two angles together equal 180. So I should be able to subtract 180 minus 108 to 7. So 72 degrees. So the exterior angle is 72 degrees. And because all the interior angles are the same, all the exterior angles are also going to be the same. And how many exterior angles are there? There are 5. So one exterior angle is 180 minus 108, which is 72 degrees. Okay. Then finally, if we want to do all the exterior angles, each one is 72, and there are 5 of them, and that's going to equal 360. So all the exterior angles, when you add them together, make 360. So because each exterior and each interior angle are going to be supplementary, they're always going to add to 180. Then that means the sum of the measures of the exterior angles are always going to be 360. So if you want one exterior angle, you're going to take 360 and you're going to divide it by how many sides there are, how many angles there are. So if you think about it, 10.1, we talked about this, and we talked about this. Here we are in 10.2. Now we're talking about exterior angles. So let's give it a little practice and see how we do. Okay, we have a regular hexagon. Hexagons have 6 sides. So we want the sum of the exterior angles, which we already said is always, always, always 360. So that means each angle, exterior angle of a hexagon is going to be 360 divided by 6, which is 60 degrees. Okay, now let's work backwards. The exterior angle is 45. We want to know how many sides. So n, we don't know. So we have 360 divided by n equals 45. And when we did our trigonometry, we cross multiplied, so we had 360 equals 45n. Divide both sides by 45. And we end up with n equals 8. And if n equals 8, we have 8 sides. That means we have an octagon. Okay. Now we have a different one. Still exterior angles, but what if the angles are 40 degrees? So we should have more sides as the angle gets smaller. Let's see if that works. So we have 360 over n equals 40 this time. So we're going to cross multiply. 40n equals 360. Divide by 40. N equals 9. And 9 sides would make a nonagon. Okay, now make sure you're paying attention because we just switched to interior angles. And we're talking about each one. So when we're talking about one interior angle, we're going to go back to our equation for interior angles. Okay, and we know that this equation we have is equal to 140. So what I'm going to do is I'm going to cross multiply again, just like I was doing before. And I'm going to have 180 times n minus 2 equals 140n. I'm going to go ahead and distribute. So I have 180n minus 360 equals 140n. I'm going to subtract 180 from both sides, 180n, which is going to make it negative, but that's okay because my 360 is negative. So 180 minus 140 is just 40, negative 40n. So when I divide by negative 40, my negatives cancel out, and I end up with n equals 9, which is our nonagon again. Nonagon again. Okay, so the interior angles of a nonagon are 140. The exterior angles are 40, which makes sense because that adds up to 180. Okay, here we are. Again, we're doing interior angles. We're talking about the sum of the interior angles, and here's what they add up to. So we're going to use the equation from 10.1. Okay, and I can distribute my 180, but I'm going to go ahead and just divide by 180 to get rid of it before I start multiplying. So I have n minus 2 equals, and 18 goes into 230 13 times. So n minus 2 equals 13, but I need to add 2 to both sides. So I end up with n equals 15. So I have a 15-sided polygon for the angles to add up to 2340. And I don't know if y'all talked about it, but if you want to name a 15-sided, it's a 15-gon. So there you go.